Hello guys, welcome to Blue Tech Empire Python tutorials. In this example or in this video, we are going to be looking at some examples on using numbers. So we are going to be looking at average calculator, decimal to hex, that's decimal to hex, oct, bin calculator, and quadratic equation calculator. I'm going to be coding together with you guys, so you're going to be understanding how programming itself is done. At least you're going to learn how programmers code. If you're already a programmer, might be you're going to learn one or two things. So let's jump directly into the video so we don't waste a lot of time. Um, now, we're going to use Visual Studio Code. If you don't have Visual Studio Code, you can probably check the video where I did that. In that video, I actually showed you guys how to install Visual Studio Code on your computer for the first time. And there, we also talked about installing Python. So there's also a video on installing Python. You can get, you can also look for that on the channel and watch it. I think it's the first video of this channel. You can also watch it so that you're going to know how to install Python on your computer. Now, moving to the video, to the content of this video, we are going to be looking on how to design the first application, which is the average calculator. So I'm going to launch Visual Studio Code. I'm like get it on full screen. You got it on Control Plus. Going to do some expanding. Yeah. Now I think we are good to go. I'm going to wipe this off, and I might start like save it as file, save as, save it on my desktop. Save it on my desktop, save it on my desktop, and I'm going to give it a name average. Now you can save it as .py, but Visual Studio Code is going to help us, so we don't need to add the .py to the file, but we can add it, no problem, you know. So let's move. So the first thing is we can start with the comments like this program computes the average of numbers entered by a user. Go to the second line. The program stops when the user enters the number -1. So the program is going to stop once the user enters the number -1. Let's move to the next step. So what we're going to do is, since this is the I think sixth video, we haven't learned a lot about if statements, while statements, and the rest. So I'm just going to show a basic example on how to do this exercise. We're going to use a complex example since we haven't learned a lot at this point. So now, initially, we're going to be taking numbers from the user. So we want to write this program. We'll execute this program in a while loop. So, but we will be saving these numbers, let's say, in a list. For now, we haven't learned about this, but we are going to use it in this example. So let's just say numbers equals to, we have a list of items. So Python, here is how you create a list. A list can contain multiple variables. Now, remember, if the user enters -1, the program is going to just calculate the average. It means the user is done. So we're going to get to a while loop. And from what we while through an infinite loop, it means it's going to run forever. Now, while through asks the user to get an input from the user. We can have it as a float. We can say user input equal to uh, let's see, unexpected indentation. All right, so that's some of the uses of an id. User input equals to float because the user can enter a decimal point. Float inputs, get something from the user and tell the user enter 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 a number. So it's normally supposed to be enter a number. So initially we can say average equal to 0. So the user enters no number, we just print average at 0. All right, so enter a number. Normally we can make this nicer, enter the first number, enter the second number, enter the third number, enter the fourth number, but or enter number 1, enter number 2. We can do that. So let's do that. Let's start from counter equal to 1. So we're going to be incrementing counter. So we're going to say while user input equals to float input, enter a number, or number enter number enter number and let's say enter number plus convert it to a string because counter is an integer. Counter, so number, then we'll have to append it to something. You don't need to, it's just like we are trying to attach this string now to this text, so it's going to end looking nice. Enter number something. Counter initially is going to be enter number 1 because remember at this point counter is 1, so it's going to be enter number 1. So user input, let's have this here. All right, user input equals to float, enter number, str counter 1. All right, so we first check if the user input equal to -1, we're gonna quit. So we can use braces or not. Previous from the C background, we want to use that. All right, in this case we have to break, means we want to stop the infinite loop if the user enters 1. If not, then we're going to append what the user enter to numbers. So numbers.append, we're going to get the user input. So that's what we're going to do continuously. At this point, we're going to increment counter by 1 plus equal to 1. Is there anything we need to do? So we just keep taking numbers, appending. All right, so at the end of the loop, at this point, the user might have entered number 1, or it's 3 billion years, and the program can't just keep running. That's a joke. Maybe the program can run for more than 1 billion years. I don't know. So now, what do we do now? We try to calculate the average. We use a for loop, or we just use the sum, the inbuilt sum. We can say average, or we can say we can sum the items in the list, but let's just check if counter it's still 1, if counter is still 1, or if the length of the list, if length of the list of numbers is equal to 0. In the case the user entered -1 as the first number, you need to handle that. We can just say average equal to 0, maybe 0.0. All right, so it should be a float. Else we can now calculate the average. We can say else you know, average should just be the sum of the items here divided by the length of the items. So we're just gonna say else average equals to sum numbers divided by length numbers, and we're good to go. And we can say, and give a nice message to the user, the average of the numbers this, and we can say average. So at this point we are almost done, but at this point we are almost done. So the average of the numbers you entered is average. Now let's try to run the code. Let's see. All right, so let's try to run the code. Enter number 1, 50. Enter number 2. Oh, I'm somewhere else. I need to be here. All right, so enter number 1, 50. Enter number 2, 7. Enter number 3, 4. Enter number 20, 20, 26, 25. And it's just gonna keep going. I need to tell it, all right, I want to stop. And to do that, I'm gonna enter -1, and it's gonna give me the average of the number you entered is 27.5. So there is our simple program. It just did some simple things like I'm gonna show you guys. It just did some simple things. Created an empty list. Numbers empty list is initialize average to 0, initialize counter to 0. You know, from here we use the while loop. We went through while loop. It runs continuously. It does this, come back, does this. But if user input is equals to -1, we call the break. So it goes out of the while loop. We're gonna learn while loop in a different video. Yeah, so now what happens is you say you told the user to give you something, enter number plus str counter. Remember, every iteration of the loop we are incrementing counter by 1. So the first time counter is going to be 1, the second time is going to be 2, the third time is going to be 3, the fourth time is going to be 4, the fifth time is going to be 5. So you're going to have enter number 1, number 2, number 3. You see how we increment counter here. This is equivalent to writing counter equals to counter. So counter was 1. So we can write like this, but we ain't gonna write like this. Here is a short form. We're gonna learn this short form plus and. This is the short form. It's an assignment operator. We're gonna learn it when we study operators in Python. I think there's gonna be in a later video. So here is a simple. We now, once the user doesn't enter -1, the program is going to reach here. The execution is going to reach here. We append numbers with the user input. Whatever the user inputs, we append it to this list. So the list is going to keep accumulating. You can also call it accumulator. Now, after a certain point, once the user enters -1, execution of the body of the while statement is broken, and we now have the if, the length of the numbers. We want to check how many items are here. You don't want to do division by 0 because division by 0 is going to give you an error. So you want to make sure it's not 0, that the list contains some value. So in this case, we tested to make sure there's no division by 0. So if the user doesn't enter any value, we prevent this to be 0, because len numbers will have been 0 if the user doesn't enter any value. In this case, we just print average equals 0. I mean, we assign 0.0 to average. If not, then average should be sum of numbers, which should if whatever count last. If you have 10 items here, this is going to be 10 all over length. Sum of numbers, sorry, whatever is here is going to sum everything together, and that's what you're going to get as a result here. Yeah, while this is going to give you the length, the number of items. So average is equal to sum of numbers all over average. So you're going to get, now we print a good message to the user. The average of the numbers you enter is average. This average here, and here. So now we can run this code trying to see what is going to happen if we write 0, 0, or we just give -1. It means we did not enter any value. The average of the number is -1. What if we didn't do that? Maybe we didn't check for that, and we just went on and did what we like. Like if we didn't check for this and we just said average equal to like this, what would have happened if we entered -1 initially? The code will have crashed because we'll have attempted to divide by 0. So it will have given us a 0 division error. That's an exception. We can actually be able to cache that exception if we use the try except block, but we're going to learn that in the future. So for now, we had to make sure we handle that by using this piece of code. If len equals to of numbers is 0, then just display it. Don't attempt to calculate, or else you're going to get division by 0 error. So let's move to the next exercise now. So we're going to save this and we're going to close it. I'm going to open a new file. In this file, we're going to look at the next example, which is let's take hex oct bin calculator. So we're going to type first. Now let's try to save this. Save as desktop. Desktop. What's the desktop? Desktop. All right, so we're gonna write bin to hex oct bin. Okay, decimal, not bin, dec bin calculator. Doesn't look good, so we're gonna write use underscore so the name looks somehow good. All right, so next we're going directly to the coding. Now we can write dot py like we're gonna write p. We want to see some Python stuff here, so Python, we need to see Python. All right, so in this case now we're saving our desktop. All right, so there is a comment. This program um accepts decimal number from the user and prints out its hexadecimal, octal, and binary equivalent. All right, so now very easy. We simply start by saying and since we collect a decimal, we can say decimal number. Decimal is equal to input. We want to, it should be an int. For example, let's make things simpler. Let it be an int. So we convert to an int after calling input. Enter decimal number for conversion. So enter decimal number for conversion, and next what we do is after the user enters a number, we start our conversion right away. This is a very simple program. So we can say hexadecimal equals to hex, like we saw in the last video. Hex, if you haven't watched the last video, you can watch it to see on Python numbers. So hexadecimal equals to hexadecimal. We have octal equals to oct decimal, and lastly we have binary 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 equals to bin decimal, and we can form a very nice message for the user, called message, and we can say something is equivalent to, and we can say we can use the /n. We can start by saying hexadecimal, and what is the hexadecimal? We go to the next backslash, new line, we say octal, what's octal, something, and we say the last one, we say binary, what binary, something. Now these are called placeholders for the string format method. We're going to learn all this, and these are just examples you can come back to after you've learned Python properly from the other videos on the channel. So here we now have to fill these spaces. The first one is decimal. The second one is hexadecimal. Remember, these are all identifiers we have declared. So we want to say whatever decimal is equivalent to the hexadecimal here. The octal here, we write octal. Next is octal, and lastly we have binary. So binary. Now these are called placeholders. These stuffs actually replace them here, and binary in this last one. And now this /n means new line. It means the key during the output, the console is going to print. When it reaches here, it moves to the next line, continue printing from here. When it reaches here, it moves to the next line, continue printing. When it reaches here, it moves to the next line. So this slash n are not actually printed out. If you check, the color is a little bit different. They just give some instruction to the print statement. Please, once you reach here, move to the next line and continue. So that's all. Now we're moving to the next statement. Now we just print our complex message. So let's see what we get. All right, so let's see what we can get from the output right here. All right, now let's clear. Let's just use something like Z, and let's clear our, yeah. So now let's run this again, and we get enter decimal number for conversion. Well, let's see 60. It says hexadecimal OX 3F, OO 7F, this thing. And here we go. We have a perfect converter. It's converted 60. We can try it again. Let's say 200, and you get it OXSC. Now let's say 256, because a lot of people know 256 is FF in hexadecimal. So let's be sure. Or is it 255? Yeah, so 255 is FF in hexadecimal, or 377, and in binary, we know it consumes all the 8 bytes, or the 8 bits with 1, 1, 1, 1, 1. So this program is complete. We can clap for ourselves. And let's see. Now, you may look at the program and say, oh, doesn't look very good. Why should we have, why should we have, you may say, oh, doesn't look very good. For example, why should we have 0, 0, all this stuff? How can we remove the 0? Oh, it's very easy. Since this is a bit complex, if you don't understand, you can drop it for the meantime. This stuff is a string. You understand? This, for example, look, hex will return a string. Let me show you how to look at the documentation. You see the documentation returns the hexadecimal representation of an integer. Here is the return type. It's str. So you can use the index operator to start from the first, let me say the second, because you want to cut out this crap. Let me show you. You want to cut out this crap, this 0x, this 0, 0, and this 0b. So what you want to do is to index such that you skip the first two characters within the text and continue from there onward. So we're going to use the slice operator to do that. Very easy. We can say, let's fix this first. We can just say hex, and we slice it starting from the second index, 0, 1, 2, and to the end. There is it. So we're good now. um we good now we good now. Let's check if that simple modification works. We're going to learn all that later on. So let's see if that simple modification works. All right, so we want to try 200. Oh, it worked. Hexadecimal C8, octal 310, and binary 10. We no longer have that ugly OX, OO, or OB. So there is a way. Let's try it for 500. 500. So, all right, so we're good to go. All right, so we're done with this exercise, and we're going to go directly to the next exercise. So I guess you've understood this. So let's move to the next exercise. So we're gonna save this, and we're gonna cancel this. Our next exercise is a bit difficult. It's a quadratic equation calculator, and we're gonna show you an example here. Let's look for a big eraser to wipe this off. So we're wiping this off like right. So like wiping this off. All right, so simple. Now we know the equation of quadratic equation is minus b. For those who did some maths in school, minus b plus, oh, I'm so slow to write on the computer, plus or minus the square root of, trying to be neat, of b square minus 4 4a c all over 2a. We can separate this to, this is 2, we can separate this to two different variables. One of the roots x, oh sorry for this, one of the root x1, one of the root x1 can be, we can say x1, s1 is equals to minus b plus the square root of b squared minus 4 a b c. So we can say all over 2a. It's so sad we have to write all this, and oh, so long. So, and we can say the next root is the next root can be simply x2. Try to save some space here. X2 equal to minus b plus minus, because we already used. So here is what we are trying to do in our program. B squared minus 4 AC all over 2 all this on 2a. So we want to do this. We want to find two roots of an equation. We're going to go straight into the programming. Like, we're going to pop up Visual Studio, create a new file, and once we're going to try to save it on our desktop, and we're going to call that file quad equation calculator. So I'm going to choose Python by looking for P. It's very simple. You can just simply add the .py. You don't even need, if you're in all files, for example, you just need to write .py here. Just need to write .py. Make sure it's at the desktop. So save. All right. So everything works well. So this program calculates the square root of a quad equation. All right, very simple now. So what we want to do is we need three values from the user, as you can see from our small board here. We need a, we need b, a. These equations are in the form x squared plus, for those who don't know mathematics, pardon us, bx, sorry, plus c. These are how equations are in the form x squared plus bx plus c. Now we can get x. In this case, x is 1, b here is b, and c is c. So we can say normally it's in the form ax, sorry, ax squared plus bx plus c. So we have ax squared plus bx plus c. Now we can now move to ask the user for a, we can ask the user for b, and we can ask the user for c, so that we can calculate x1 and x2 by doing this complex stuff here. So let's go ahead and ask the user for a, b, c. So we're going to tell the user what he or she is doing. All right, we're going to say print quadratic equation calculator. Remember, A, B, or C can be decimal points. So we're going to convert everything to float. A equals to, we're going to put this in a while loop so that it runs forever. While true, we can say A equal to, it's a float, input, enter the value for A. Next, instead of writing multiple things which can copy, programmers like copying stuff, but copying is very dangerous because you need to cross-check everything you copy to make sure nothing is left behind. Enter the value for B, and here we have entered the value for C. Now we can start our calculation, and we can use a comment, calculation. This one helps us. Python has nothing to do with our comment. Calculation starts here. Now, what we want to do is we want to find first, Python has complex numbers, so you don't need to be afraid if it has complex roots, but you need to make sure A is not 0. If A is 0, let's assume A is not going to be 0. If A is 0, we don't have, let me show you what I mean. A can never be 0 because if A is 0, then it's now a linear equation because it's quadratic because we have a value for A, because 0x squared is the same as, it's like nothing. So it's just the same as 0x squared plus bx plus c is the same as bx plus c, which is a linear equation. So a quadratic equation must have a value for A. So we don't need to worry about division by 0 because A is never going to be 0 for a quadratic equation. So we're going straight to the code, and where is our Visual Studio Code? All right, so now we want to calculate first b squared minus 4ac. It's called the determinant. So I don't know if I'm correct. I'm forgetting a lot of mathematics now. So we can say determinant equals to, is the square root of b squared minus 4ac. So we're gonna say b squared, is this the power for raised to the power 2, b squared minus, try to put this in bracket, b squared e raised to the power 2 minus 4 times a times c. So let's join things together so we know minus 4 times a times c. All of this is raised to the power half. It's the square root, so it's raised to the power half. I'm trying to show you this. You see, you have b squared minus 4ac. The square root means raised to the power half. So we have here we have b squared minus 4ac all raised to the power half. So that's the determinant. So we can say x, that's x1 equals to negative b plus the square root of b squared minus 4ac is determinant all over 2a all over divided by 2 times a, while x2 the second root is equals to minus b. You see it is equal to minus b. We had it here, minus b. Now minus determinant. The other one was plus determinant. In this case is minus, or this determinant we calculated all over 2a. So we're just going to write minus b minus b minus all, yeah. So now we can say, we can write now print the roots of this quadratic equation. We can make the message complex, but let's make it simple equation, like by writing the roots of the quadratic equation ax squared plus this whatever is, stop there. Let's just make it simple to save time. Is, now we can just write is something and something. Let's now find that something dot format. The first something is x1 and the second something is x2. Now let's end this with new line. So the next request from the while loop prints on a totally new line. So here is a simple code. Let's see if it runs. Enter value for a. Let's have some example 6. Enter value for b 11. Enter value for c negative 35. Go to the quadratic. Oh yeah, we have it. Now let's try 2. Enter 4 or negative 4. Negative 4. Now let's enter negative 2. We have some long roots. We're gonna seek some complex roots. That's what I'm looking for. Let's enter 20. Let's enter negative 15, and let's get negative 10. All right, here we don't have complex roots. We're gonna look for complex root 1 for a. That's 1x squared minus x, so minus 1 for b. And c, we can say 3 minus 3 minus 3. Let's see. All right, yeah, we don't have complex roots. Let's try again. 5x squared plus minus 2x plus 1. All right, here we have complex roots, as you can see. I just wanted to see it's possible. Let's try again. So let's use 3x squared plus 4x plus 2. Here we have complex roots. And lastly, let's try negative x squared, that's negative 1, plus 6x plus 6x plus 18. And here we have normal real roots. So there is a simple exercise, and just to explain, we just took different inputs from the users, converted them to float ABC. We calculated the determinant b squared minus 4ac all to the power half. That's the square root of b squared minus 4ac. We now take now minus b plus or minus the square root of plus the square root of b squared minus 4ac all over 2a. Then we took minus b minus the square root of b squared minus 4ac all over 2a. So very simple, and that's the Python code for you. So that's the end of this video. I just wanted to show you a few examples using numbers. See you in the next videos. In the next video where we're going to be talking about Python strings. All right, later.